Okay, we are live.
Right, good morning and welcome to the House Environment Committee. This morning, excuse me, we're going to hear about the Vermont Atlas of Life or the Vermont Center, from the Vermont Center for Eco Studies. I do want to just make one public service announcement before we get started. Our agenda says 1 p.m. to be determined. We do not have anything scheduled for 1 p.m. today, so we will be adjourning after this meeting this morning. So, welcome, Emily Anderson. And are you still having trouble with your computer?
I'm just waiting to get back on the Zoom. No, I'm not in the waiting room. I'm waiting for the internet to come back. It says I'm connected, but it's taking a second. And you can't see it anymore. Thank you all. This is what I get for getting here early and getting all the tech supposedly worked out ahead of time. Let's see here.
He goes and punish.
No, exactly.
It's
It's working on it. All right, now the Zoom is launching.
We all have access to your slides on our devices as well.
Perfect. Love to hear. It really is slow today.
Thank you.
Sometimes I have to go back into settings and turn off my Wi-Fi and turn it back on when it doesn't go. Do you have a little bar?
It's full. It's
Okay.
just probably a lot of people using it.
You want to just, can you pull it up for yourself to follow? And then we can follow it on our devices.
Yeah, sure. It's almost there. But yeah, so while this gets started, as Representative Sheldon said, my name is Emily Anderson, and I'm here today from the Vermont Center for Eco Studies. And what I'm going to be talking to you all about today is specifically our Vermont Atlas of Life project and the 10-year report that we published from it last year that synthesized 8 million data points from across Vermont of species and biodiversity, representing 12,000 different species, to get a sense of a baseline of what biodiversity we have in Vermont and what the trends are looking like going forward. And part of the reason why I proposed this for today was that some of this work is helping to inform Vermont conservation design and subsequently Act 59. So there are already some applicable elements to it, and hope, sorry, I just decided to log in. And we're excited to have this be able to be available as a tool for folks going forward. And we're back. Great. Thanks for bearing with me here. So for anyone who's not already familiar with the Vermont Center for Eco Studies, we're kind of tucked away over in White River Junction, but we are a nonprofit biodiversity research center that focuses on studying wildlife and their habitats throughout Vermont, but also throughout the wider northeastern North America and all the way down into the Caribbean, because part of our focus with our research is taking a full life cycle approach to conservation. So we study one species of bird, for example, is the Bicknell's thrush, which overwinters down in the Dominican Republic and other parts of the Caribbean. And so we have scientists that go down there in the winter to study the birds there as well and work with partners in the DR. But we also study loons, we study insects, we study amphibians. And really, there aren't many habitat types in Vermont that we don't have some species of interest there. So we work everywhere from the ridgeline of Mount Mansfield and other high elevation peaks to grasslands, partnering with landowners, to lakes and ponds, to people's own backyard. And one of our big focuses with our work is empowering community members to get involved in the process of science through participating in our studies as volunteers at different levels. And we also work with landowners, we work with state agencies, we work with academic centers. So even though we're a very small nonprofit, we try to take a really broad approach to how to collect data that'll be beneficial for conservation in Vermont and beyond. And one of the reasons why this work is so important is because scientists all agree we're experiencing an unprecedented decline of biodiversity, with over 1 million species currently at risk of extinction. And with these kinds of concerning reports coming out, it's important for us to understand here in Vermont what we have, how that's going to change in the future, so that we can work on conserving it now before it disappears. And one of the big projects that came out of this desire was the Vermont Atlas of Life, also known as VAL. You may hear me refer to it as that. And the goal with VAL was filling in knowledge gaps for the state of Vermont when it comes to biodiversity. We know a lot about what the state has for birds and mammals. We have around 380 bird species. We have around 58 mammal species. But we don't know how many insect species we have, for example. There are estimates that it might be somewhere from 22 to 26,000 species, but we don't know for sure because no one's mapped and monitored those. And it's unclear of what might happen as climate change and other land use changes progress, what kind of impacts these species disappearing may have on Vermont's broader community. And so the Vermont Atlas of Life was started as a desire to fill some of these knowledge gaps and really become a living library of biodiversity for the state, with the idea that once we know more about what we have, we can work to conserve it. So when the Vermont Atlas of Life started a little over 10 years ago, it started in, I believe, 2013 or 2014. And its first goal was to mobilize primary biodiversity data and strengthen community science networks. And this is something that we have achieved. So throughout our work, we provide we have an online platform that provides real-time biodiversity data to anyone, anywhere, whoever wants to use it. So if you have a question about biodiversity in the state of Vermont, this is a place you can go to start to uncover some of these answers. This allows us to then take all of this data, track changes in biodiversity, and hopefully help inform decisions that are being made at the state level, at regional levels, and at federal levels. And we've also used it to collaborate beyond our borders with partners up in Canada, with partners in New York and New Hampshire, as well as being part of over 200 published research papers that have used our data. And finally, part of what we try to do with this project is communicate and build awareness for the importance of biodiversity and really empower people to engage in the wildlife that they have in their own backyards and take a stronger role in how they can work to understand what is there. So one of the things this map is showing is all the places in the state that are currently have points of data for a particular observation of a species. The way that the Vermont Atlas of Life collects data is that it relies on several different what are known as crowdsourced community science platforms. I don't know if anyone's ever heard of iNaturalist or eBird. There's also one called eButterfly. These are tools where anyone can use an app or their computer to upload photos of wildlife that they encounter or tick off species on checklists to record what they're encountering just going about their daily lives. So it's a very passive way for people to be involved in science, and it's a very accessible way for people to be involved in science. Because once the data goes into these platforms, it goes into a larger data storage facility called the Global Biodiversity Information Facility. There, it's available for anyone in the world to use for research, for informing land management decisions, for however they want to use it. So the Vermont Atlas of Life takes Vermont specific information from this giant database and uses it to better understand Vermont's biodiversity. So the one thing this figure is showing is that currently at the time that this screenshot was taken, there were over 10 million records of biodiversity being used by the Vermont Atlas of Life or available through the Vermont Atlas of Life for people to go in and explore of species that are found that were recorded specifically in Vermont. And there's almost 50,000 people that have contributed these observations, as you can see from the approximately 46,000 contributors. And part of the reason why this method is so important is to get a really good baseline of what kind of biodiversity we have in Vermont and what's happening with it. We don't have enough hours in the day, days in the week, weeks in a year, or enough biologist power to go out and do the amount of sampling that would take. So by encouraging folks to participate from their own backyards, we get this high quality data of, again, 10 million records that would be impossible for biologists to collect all on their own. And from that, we can begin to better understand what's happening in Vermont. And I just want to share this map because it's actually really exciting. You can see that Vermont is very dark green. And this is just showing per capita the number of observations that end up in these community science platforms. So currently Vermont is by far and wide leading the nation in the number of observations that get submitted to
Those per capita things.
Yeah.
Yeah. But this is thanks in large part to my colleagues, Kent McFarland and our other scientists at the Vermont Center for Eco Studies, because all of our projects have some component in which we're encouraging folks to go out, observe nature, submit observations. And from that, Vermont is leading in trying to understand what we have as far as biodiversity.
Does Alaska have a similar program or project happening? Because they're hot on our tail.
Yeah, that's a great question. I am not quite sure what Alaska is doing. I don't know if it's that they have a lot of people that are very passionate about nature and maybe not as many people per capita as compared to some of the other places, but I'm not quite sure about Alaska, but really it looks like Maine might be the closest in the lower 48, and we're still pretty far ahead of them.
So that's a lot of wildlife.
Yes, exactly. There's a lot to
The
say.
wildlife to person ratio is pretty good.
Yeah.
Representative Austin.
Yep. Do you have to go to another site or can you just Google eBird or iNaturalist and get to that site?
To the Vermont Atlas of Life?
No.
Or the Global Biodiversity?
Mhm.
I think you have to look up specifically the Global Biodiversity Information Facility. An easier way to say it is just GBIF, which is GBIF. I don't think there's another acronym out there that it also stands for. But it's definitely a cool site to go and explore. And if you're interested in Vermont species specifically, the Vermont Atlas of Life basically pulls in a lot of that information and has, we've had a team of biologists and software developers working really hard on it to have distribution maps and other things that would be of interest for people to go and explore Vermont.
When you're done with your presentation, could you show me how to do that? How to get to the eBird?
Yeah.
Okay, good.
I can definitely do my best. Yeah. So actually, before I was working in policy for VC, long ago, I started as their AmeriCorps member where I was helping people use these community science sites. So that's something I'm very happy to
That'd be great. Thank
happy
you.
to talk more about. And I didn't really talk more about the close-up of the Vermont map, but basically the key thing to take away from this map is the darker gray areas are clusters of where there are a lot of observations being logged. You can see that it's zoomed in kind of around the Burlington area, and it's all these color points.
But they're remarkably spread out across the state too.
Yeah, they definitely are. I mean, there are some kind of concentrated around certain cities, but I mean, it really just goes to show that folks in Vermont are recreating a lot in nature and spending a lot of time out there and are really participating in these opportunities to contribute data. And so then now we're starting to get into some of what we did with this report. So after 10 years of collecting all this data, of running the Vermont Atlas of Life and all of its sub-projects, we wanted to know, okay, so we've been doing this for 10 years. What have we found? What do we know about what's happening with biodiversity in the state? So we took 8 million observations, 8 million of those little data points from the previous page. And that, again, representing 12,000 species across Vermont. And we began to look for patterns and trends in the data of what we were seeing. So this first slide is looking at the raw numbers of how many observations do we have versus how many species are we finding? And these graphs are specifically for plants, but our data scientists ran them for all different groups of species. And so the map is color coding different biophysical regions in Vermont, just because it's one way to visualize some of the species data. But so the smaller graph in the corner, what it's showing is, so it's showing the number of observations, and then it's showing the number of plant species that were discovered. And as the graph goes up, you notice that it begins to flatten out. So as it flattens out more and more, that's indicating that we're really getting to a point where we're not discovering a lot of new species. At the beginning, when we're first logging the first few observations of plants in the state, we're pretty much getting a new species every single time that we log an observation. But after, what is this, over 180,000 observations of plants in the state, we're really not seeing that many new species anymore. And so this helps us get a sense, this shape of this curve can tell us a lot about how many new species there might be left to discover for a particular group. The graph at the right has broken this down by the different biophysical regions in Vermont. You can see it's color coded to represent the different regions shown on the map. And so for some biophysical regions, like over in the Champlain Valley area, we've discovered a lot of species. You can see that that curve is really starting to flatten out. That means that we're approaching the point at which we may not find a whole lot of new species left in that area. However, you'll notice for others, we're just barely getting past the steep vertical part of that curve, meaning that there are a lot of species left to still discover in that biophysical region. And again, this is just plants, but we have this kind of information for insects, for pretty much anything you could hope to be curious about in Vermont.
Representative Sakowitz.
Yeah, I love these graphs. They're amazing. My question is, it's this relationship where it levels off is obviously the same for each, is very similar for each, but I'm wondering if, and some of them are taller simply because there's more species, right, in certain areas and in others. But I'm just sort of wondering if the overall shape is the same and they're just like stretched, or if they really are different somehow, like
Yeah,
saying.
yeah, I totally get what you're saying. That's a great question. And I will fully admit that I am not the data scientist who crunched these numbers. So that would be a great question for our data scientist, Mike Hallworth. But I think there are some regions that are just undersampled, and like typically because they're harder to get to, or the landscape topography makes it more challenging to sample. So it's definitely possible that some of those like really are going to level out really fast. But I think the assumption is, at least with this type of modeling, that we would expect to see a little more flattening out before they got much farther. But you're right that like a lot of them just aren't going to get to the same number of species that we would expect to see.
Is that okay? Okay, I'm just still thinking about it. Yeah, thank you.
Yeah, no, it's totally fine. And so still looking at the raw numbers. So this is taking each of these biophysical regions and each group of species that we typically look at in a broader sense. And this is standardizing them by looking at the estimated number of species you would expect to be found per 1,000 observations. So for example, in the Champlain Valley, if we took 1,000 samples of birds or had 1,000 observations of birds, we would expect to see 223 species represented across those observations. And so this is just a way to start to approximate how much diversity there might be within a certain group of species in a specific area. And the main takeaway from this slide is that there really isn't one biophysical region in Vermont that you can go, I'm going to conserve everything in the Champlain Valley and then have it target the highest diversity of each of these groups of species. It really does take kind of a patchwork approach to maximize conserving the full diversity of species.
Representative Norm.
Yeah, great data. It's very interesting. Couple of questions.
Yeah.
Very interesting to know the intersection of these. So these are just raw numbers, like the 19 in the Champlain Valley and the 29 in the Northeastern Highlands. Are those two completely different sets, or are they largely overlapped, or they're same, just some more in the Highlands?
Yeah, that's a great question. We may get to that a little bit in talking about unique communities, but I'm not sure if that's something. I'm sure it's something our data scientists has specifically looked at, but I don't know.
It's got to be individual species that are those 19.
I'm sure.
Right.
Yeah, there's definitely some overlap.
Interesting.
Yeah, for sure. And that's definitely something I can ask him as well and see if that is something he has like readily available.
Cool. And then the second question is, are we counting kind of population size of each of these species using the same data? And if so, whenever it's crowdsourced, how do you know it's not like 10 different people seeing the exact same one and going, look, here, there's one, look, there's one. It's really just one, but there's 10 different people that saw it. So now it looks like 10 of them.
Yeah, that's also a great question. And I think, again, because I haven't done any of the processing of the numbers, but from my understanding, our data scientists have specific methods for accounting for some of that, whether it has to do with checking redundancy and coordinates, because each of these crowdsourced observations have coordinates attached to them. Yeah, so it might be like coordinates and dates help you get at, okay, you've got 6 observations of this one trout lily from this date at this geographic coordinate, probably good chance it's the same one.
Gotcha.
Yeah, so there is a lot, even though these are raw numbers, there is like some data cleaning that goes into this, but this is all like modeling that I'm going to start talking about next.
Thank you.
Hold on one second. I'm sure you said it and I must have missed it, but why are some of those numbers highlighted?
Oh, they're highlighted because they are the highest for that particular group of species. So for example, in the Northeastern Highlands, the 29 amphibians is the highest out of all of the biophysical regions. Yeah. Yeah, and so that was just kind of to help to make it easier to see that while there are some biophysical regions that have multiple taxon groups that are most likely to have the highest diversity in that area, there isn't one biophysical region that has all of them that are the highest. So moving on to talking a little bit about modeling. So our data scientists took all of these 8 million observations and ended up with, I believe, 15,000 different species distributions or ran 15,000 different species distribution models. The point of this was figuring out like where species might be found at specific locations given certain climate and other landscape variables. And there are certain criteria for data that have to be met for these models to run successfully. So we ended up with 7,211 species distribution models. And what this pie chart is showing is the rough representation of what proportion of these 7,000 plus distribution models pertain to each of these different taxon groups. So for example, for insects, almost 4,000 of these distributions were for insects, but that actually only represents approximately 22% of the insect species that are expected to be found in Vermont, because there were certain criteria that had to be met for the number of observations and other data quality metrics that needed to be met for these. So this is a good way to start getting at some of these more complicated questions of where certain species are found in Vermont, how that might be changing over time. But it does mean that there could be underestimates here as far as how much things are changing, because we only have 22%, 27%, 10% of these species. But it begins to allow us to answer some of these questions. And so what the map here is showing is it's showing species richness. So it's basically taking each of these slices of the pie chart and stacking them on each other and compressing them, with the warmer colors being areas of the state where you would find a greater number of species, and the cooler areas being areas where you would find fewer species. So the Champlain Valley is really lit up with warm colors, meaning that there's a lot of species richness, a lot of total numbers of species that inhabit the Champlain Valley. So this allows us to begin to see what are some areas, if we're thinking about conserving the most number of species with any given conservation action, what are some areas that might be high priorities for that based on how many species we might expect to find there? This doesn't tell us anything about how vulnerable those species might be, exactly what those species are. It's just a preliminary measure of are there a lot of species here, yes or no, on a gradient.
Representative Norton.
Question on that, is that based on the expected plateau of those curves, or just kind of where we're at? Because clearly some areas have much higher numbers of observations, therefore it could appear like there's more species there. We just, in the other cooler areas, we just haven't had enough people out there looking at stuff to make sure.
Yeah, that's a great question. And that gets at something that I didn't, that I forgot to mention again, because I'm not the data person, but that when he was going to put together these models, he also pulled a lot of observations from other areas in the Northeast to begin to get at species that aren't currently here, but whose climate preferences may push them here at some point, or to help further make the ones that we have more robust as far as climate variables that might affect where they are in the landscape. So this is reflecting not just the observations of Vermont, but kind of a overall summary of here are species that are present and based on certain climate variables, here's where they're most likely to occur.
Representative Austin.
Can you extrapolate from the percentage amount to how many actual species there are?
Yeah, so I mean, there are estimates. So like I was saying earlier, the estimate for insects, I believe, is somewhere between 22,000 to 26,000 species. And that doesn't mean that we have data for all those species or even records for all those species. It's I don't remember the exact process that went into it, but basically using certain metric scientists were able to estimate, we think there's somewhere between this many and this many species for Vermont.
So you could do it for all those.
Yeah.
Metric.
Yeah, and like I was saying, for some species like birds, we know we have about 380 bird species in Vermont. And yeah, so it begins to get at kind of what species we have, but it's not quite a full picture yet.
Thank you.
So kind of beginning to get to your question earlier about overlap. So next they wanted to look at unique communities. And so unique communities aren't necessarily areas where you have a lot of rare species together, but it's areas where you have common species together in combinations that aren't found elsewhere on the landscape. And targeting areas that harbor unique communities can help preserve or help conserve more more interesting species dynamics, because oftentimes when we're thinking about conservation, we're thinking about individual species, but we're also thinking about the relationships between those species and how that affects other natural processes. So these are areas where you might have species living together in a natural community that aren't found elsewhere in the state. And so those might be interesting areas to consider for conservation from a bigger perspective of preserving the relationships between species, as well as preserving or conserving the species themselves. And so here, a lot of the unique communities, again, are kind of concentrated in this Champlain Valley region. Champlain Valley seems to be kind of a hot spot for a lot of biodiversity in the state. So then another thing we decided to look at is using these distribution models. We wanted to see how these lined up with currently conserved lands in the state to see how effectively current conservation is protecting some of the species that need it the most. So there were a lot of different ways that this was broken down. It was broken down into public and private conservation. But here is showing the different percentages of conserved land by different levels of ranking of species. So for those who aren't familiar with looking at what we call S rankings, S5 are species that are very secure, things that you see all the time, like raccoons, for example. All the way down to S1, which are things that are critically imperiled, meaning that they're only found in very, very small areas of the geographic location, and they're not doing so well in those areas. And so what we found from looking at this is that their current conservation lands are protecting secure species and critically imperiled species the same amount, meaning that there could be opportunities here to consider conservation that may further protect some of the species that are greatest conservation need. Because when we think about conservation, oftentimes we're thinking about wanting to have conservation easements and other practices in place in areas where it's going to make the most benefit for the species that are having the hardest time. And currently, as they are configured, that may not be the case.
Yeah, I'm just thinking what was just said, Representative North.
Does the conservation lands here include current use?
That's a great question. I don't know exactly what went into the private versus public.
It's not.
It's not. Okay. What I do know is that it's not on this slide, but that conservation efforts on private lands were shown to be conserving a higher percentage of these species than public lands. And I think some of that has to do with, as well, Vermont is just a higher percentage of private land versus public land in general.
Oh, yeah, Representative Pritchard.
So how do you identify the one I'm interested is on the hook down below, because I know that's the Gaelic Preserve in
Yeah.
West Haven. So where is that, an S1, an S2, an S3? Because I know they have a couple species. One, I think the skink is the only
Yeah.
place that it exists. And then of course the rattlesnakes. But how do you find what rating they are? Are they an S1?
Oh yeah, good question. So the S rankings are for individual species. So it's like any one of those gray shaded areas might have one S1 species and 24 S5 species in it or something like that. So it's more that out of these gray areas that represent conservation land, across all of those gray areas, they are conserving 12% of the S5 species for the state, as well as 12% of the S1 species for the state. That doesn't mean they're evenly distributed across all of it. It just means that if you were to group all that land together as 100%, 12% of the species found in that would be S1.
Well, and can you just repeat again what you think the take-home message there was about opportunities for, I guess, more focus on critically imperiled species?
Yeah, so the findings from this report indicate that there could be an opportunity here for conservation that for new conservation that better targets some of these critically imperiled species, because since both secure and critically imperiled at 12%, it's showing that it's not what you would maybe expect to see is that critically imperiled receives greater coverage by conservation land if conservation land is specifically targeting some of these rarer at-risk species. Currently, with both being at 12%, it's not really covering the critically imperiled species more than the others. So there could be that there are opportunities here to better target conservation land for some of these critically imperiled species.
Although I would say it's possible that the 17%, which is the highest in S2, they could have all been S1s that became less-
Exactly.
because the Nature Conservancy did something about it. And I'm
Yeah.
guessing that's what you mean by private lands, because for decades, that was their focus. And now we're moving towards more landscape, the whole coarse filter idea of capturing more species for the conservation buck.
Yeah, absolutely. And this doesn't really get to any of that. It's more of just a snapshot in time. So this is not saying this is not like the definitive word on conservation land in Vermont isn't effective or anything like that. That is not what this is saying at all. It's more just saying when thinking about new land to conserve, there could be opportunities here to look at some of those species that are still S1, see where their current distribution is on the Vermont landscape. And when thinking of areas to prioritize for future conservation, considering areas that might have some of these might boost the number of S1 species for the state that are on conservation land.
Representative Austin.
Would it be possible to get another slide or information on the S2 and S1 animals, like what they are and then where they are in the state?
Yeah, and I believe I want to say Fish and Wildlife and some of the other Vermont agencies do have that information.
Yeah, we can have them in on that.
Yeah.
We're the keepers of that database.
Okay.
Yeah.
It's in SACROS.
I'm guessing you probably don't know the answer to this question, but I would love to find it out if you can look it up at some point or ask somebody, but all those percentages are fairly closely clumped. And I'm wondering if the differences between them, how much of that is just due to random chance?
Yeah, that's what.
And how much is actively, implying something that is actually going on in the landscape because of conservation measures like rep Sheldon just.
Yeah.
It's going to be both. It's the Green Mountain National Forest is just the big area, and then the Nature Conservancy's been targeting other conservation groups as well.
Yeah, absolutely. That's a great question that I don't know the answer to off the top of my head. And we do have, I have both a hard copy of the report here with me that I can leave with you all, as well as we do have a PDF version available on our website. And that also dives much more into a lot of these figures and methods and stuff like that. It is very dense, which is why I left a lot of it out.
Thank you.
And so another thing, as we begin to look at how species may change under certain climate change scenarios, for example, here, RCP 8.5, which is business as usual, we can begin to get a picture of what species are might be lost or gained for the state. And so this figure, anything in the negatives is species that are being lost, anything the positives are species that are being gained. So you can see for a lot of these, there's kind of this flow between, yes, we're losing species, but we're also going to be gaining species, whether through migrating up from Massachusetts and areas south of us, or species that are introduced from other areas. But ultimately, overall, under business as usual carbon emission scenarios, this report predicts that we could lose as many as 386 species, or 6% of the species in Vermont, under business as usual climate change.
Representative Tagliavia.
Taking into consideration what you just introduced with this slide, I can't remember if it was yesterday or the day before, we heard testimony about how at some point in Earth's history, Vermont, where we're sitting, was under a mile of ice. And like you said, species moving and migrating, obviously something that could exist right after or during the glacial time couldn't exist now. And how much of this, the studies that your organization has done is taken into consideration the natural extinctions and then moving of species simply because over our history, temperatures have changed here?
Yeah, that's a great question. I mean, one of the biggest challenges with species moving in and species moving out, it's not, 6% doesn't sound like a lot of species change, but that is a net loss. So we are going to be losing a lot more species than that. And the challenge with that is some of the species that we're losing might be species that have really key relationships in their natural environment that aren't easily replaced by species coming in from other places. So, for example, there are a lot of agricultural crops that are pollinated by very specific types of bees. And if those bees disappear, we may get other bees coming in from Massachusetts or other areas. But the problem with that is they may not fill those gaps that are then left by the bees that disappeared. So you may end up with kind of overall, not too much of a net loss of species, but you may end up with gaping holes in the ecological relationships that a lot of our systems in Vermont rely on. So that is the one challenge kind of with species migrating in and out. And you end up with species that are typically found in one area that might migrate upslope higher in latitude. And that is a natural response to temperature changes and stuff like that. But it may mean that those species aren't able to find food as easily and may have a different relationship with their natural environment that may lead to impacts that we can't at this moment anticipate that might be felt by people. So it's just something to keep in mind when looking at these numbers of, even though 6% doesn't sound like a lot of change, it's unclear of exactly what that could mean for the ecological relationships that those species are a part of.
Yeah. Okay.
Looking back in history, is that about the same 6% plus or minus? Taking man out of the equation from like 200, 300, 400 years ago, would that have been, was there any modeling to see 6% losses projected? Would that have been typical?
But I mean, given that this model was run under the kind of business as usual carbon emissions scenario, and without people, we probably wouldn't be in that emission scenario. I think it's fair to say that we would see a different percent change in species. That's not to say that I can't say what that percent change would be, but I can say it would probably be different given that this is a response to this particular rate of carbon emissions and the effects that it has on the environment.
Maybe another way of saying, well, just wondering, how do they do that? How do they estimate this? Who's RCP? How's it estimated? And but it may not be, you may not have the answer right now. That's fair. I'm fine. But just curious when I'm like, you're sort of asking like,
Yeah.
what is how's it done? And then what's the control? How do we
Yeah,
control
totally.
for that?
Yeah, absolutely. And that is totally a fair question. I don't know the answer to that right now, but I can ask our biologists and try to get an answer for you on that.
Underlying assumptions going into that.
Right.
It's only as good as its assumption.
Yeah, I would actually say that 6% is sort of alarming because 2100s in the scheme of things isn't all that long from now. And if we were to continue at that rate, we're in pretty bad shape. But my question is really about, well, two questions. One is that 386, that's 86 species that exist here now, which will no longer predicted to be here in 2100. That's not a net number of loss and gain.
Yeah, that is 386 species that are no longer predicted to be here. And I will say this is most likely an underestimate because we only had models for like 7,000 species. Again, there are way more species in Vermont than that. So the 386 represents species that are currently in Vermont based on the modeling we did, and that will by 2100 most likely not occur within Vermont anymore. But there could be more than that because of the limitations to how many models we could run.
Okay. Yeah, so that gets to my second question, which was, given that you said there's something like 20,000 estimated insect species, 386 out of that is a lot less than 6%. So that 386 is really just predicted under this very restricted model. But if we extrapolate out to the numbers of species that we actually really think exist in Vermont, that number is going to be much higher.
Yes, yeah, it definitely could be. But yeah, so this is most likely an underestimate because these are based off of the 7,000 plus models that we could run.
Right, but we actually think there's more, there's like 10, not 7,000 species in Vermont, but tens of thousands.
Exactly.
So it's easily 10 times probably on that order of magnitude, something like that, greater than that number. We're really looking at losing thousands of species, likely.
It could be, I think it's challenging to say exactly without running models for all those species, but it is definitely
Just
more than
assumed
that.
some sort of proportional relationship, which could be wrong, but doesn't seem crazy. We would be looking at thousands of species.
Representative
It
Pritchard.
would be interesting to know, how the species that are going away, are they affected by the invasive species that are coming in?
That's a great question. I mean, it's definitely a very species to species specific
And is that
basis,
number
but
always changing because of that?
it could
Because
be.
it has to, it has to.
Yeah, exactly. I mean, it
I mean,
definitely.
this is a net number you're giving here, right?
Yeah, I mean, it definitely could be. Yeah, I mean, because you can see here, like for the insect projected lost, like it's just with these models projected to lose over 600 insect species, but then gaining over 200 insect species. But gaining those species, those could be invasive species that have very different roles in their environment. And
But if it's the ash borer or the murder hornet, good riddance.
yeah, exactly. Yeah, exactly. I mean, this does not get to like specifics of
Yeah.
what species are coming in,
Yeah.
what species are going out, but definitely invasive species and the relationships they have with native species does play a role in kind of all of
Sure.
these declines. And so then another thing that this modeling allowed us to look at was the velocity of change in the richest of species across the landscape over time. So basically, this means that we calculated between today and 2100, how quickly are we expecting these areas to actually change in species richness? Areas with a low rate of change are considered to be species richness refugias, basically areas where we won't expect to see a significant change in the number of species there and the composition of those communities over the next or before 2100. They might support a similar number of species within each taxonomic class into the future. These are areas that, again, could be beneficial for conservation easements and stuff like that if they're not already included in those, because they are areas that may experience a lower rate of change in the species that are found there and can help preserve some of the community structures we recognize in Vermont's natural communities.
There's a lot behind this that I'm sure we have questions on. I think we will, you said you brought one copy of the report. Yeah, that's great. What I would say is that we're going to, I think it's a good idea for us to have a library members, and we've started one over there. And that, rather than all of us accumulating, we could take things out and borrow them and return them.
Yeah,
We'll
and
add
I
that.
can also, this was the only copy I had with me, but we have more copies in my office that I can bring in.
We made one. Yeah, it's also online.
Yeah,
So I think it's fair. We're trying to use fewer resources,
totally makes sense.
have the appropriate number of resources.
Yeah, totally makes sense.
I'm seeing some of Larry's nature observations.
Yay.
Yay.
Thanks, Larry.
I'll bring this
Are you
down, but
submitting?
when I did a little deeper dive on this,
Oh, wow, that's beautiful.
very nocturnal.
Yeah, Luna moths are one of my favorites.
There's the
Oh,
name.
yeah, another sphinx moth. Right.
They're large.
Yeah, they're
I mean,
astonishingly
right.
large. Yeah.
It's on my barn door.
Oh, cool. That's awesome.
That's great.
Another observation I had in my own book.
Representative Austin, did you have something?
When it says if the proper habitat is available,
So, yeah, so that just means that that those species can continue to be found there if the habitat that is present there continues to have the things needed to support them. So some of these species richness refugia are also assuming that the habitat qualities that are there don't really change due to other things beyond climate change.
Like human land use changes.
Yeah, exactly.
Gotcha.
Representative Labor, it's hard for me to see you over there sometimes.
One of the species, plant species that I've noticed that are diminishing in my woods, you had a nice slide opening, showed a beautiful pink lady sliver. I used to have them. Now the only ones I have are white lady slivers. In your field observations, is that diminishing north to south?
Oh, that's a great question. I don't have anything specifically on lady slippers, but I do know like one project that's done in Vermont as well as Massachusetts and throughout the Northeast is tracking what is called like the phenology of wildflowers. So when they bloom in the spring each year, and they've been tracking that for over 100 years now and finding that wildflowers are blooming in different locations and at earlier and earlier times as it gets warmer in the spring each year.
I've been tracking lady slippers by my house, and the population I've been tracking has been expanding on a sort of a south-facing rocky spot in the Green Mountain National Forest.
Yeah.
Tracking for about 20 years, and this population has grown.
Oh, cool.
Pretty significantly. It's kind of
Yeah.
cool.
And that, and that really speaks to some of the challenges with this, where it's like, we can say that, across the entire state of Vermont, here are some trends we might expect to see, but in your own backyard, you may see something become more common. And it just kind of gets at, there's a lot of variability across the landscape that allows things to flourish in different ways across it. So that's really cool. And so finally, to get back to some of what I was saying earlier, is this study and a lot of the work by Vermont Atlas of Life is being used by folks at Vermont Fish and Wildlife to help inform some of the Vermont conservation design. And we currently have a postdoc who just started earlier or late in 2024. And part of his role is looking at about 40 different species of varying habitat requirements and prevalence across the landscape, and seeing how where they're found and where they might be found in the future fits into Vermont conservation design. So to kind of help the folks at Vermont Fish and Wildlife continue to grow and improve this product that is being used for Act 59 and that will be really beneficial for land use planning in Vermont going forward. And we're super grateful to them for this opportunity to participate in this process. And I can expect over this next year, you'll be hearing more about our postdoc Brian and some of his work and how it connects further into Vermont conservation design.
And are you working with, I mean, I assume you are, but like, how does the Nature Conservancy use your data, other conservation partners?
Yeah, they do. Maybe to a lesser extent, I will say like Vermont Fish and Wildlife tends to be one of our major partners, but we do definitely get inquiries from other folks, and our staff sits on the species advisory groups as well and play roles in that way. So there are a lot of like smaller ways that we participate in conservation across the state, even if we ourselves don't do any. We're not a land conservation organization, but we try to make information like this as available as possible to the folks who are making these decisions so that we can help support their work.
Representative Miller.
Yeah, again, a couple of questions. First is the Vermont Atlas of Life and all the work that goes into this, is that a state-funded activity? Vermont state-funded?
Great question. We are funded by the APIS by National Family Foundation, Charles and E. So we're founded by both private foundations. We're funded by state grants. We're funded by individual people, academic institutions. So it's really kind of a,
What is the level of state funding?
ooh, that's a great question. That I don't unfortunately know off the top of my head.
The other, I guess, more statement than question is, I have a lot of experience in mathematical modeling. It's kind of my background. Just gonna say this for the record, that all the numbers that we see in the presentation are based on models. All of the predictions, everything are based on models with, admittedly at this point, unknown assumptions and rather incomplete and what was pretty clearly, I'll call it biased data. In other words, the data is very highly collected from those 4 specific areas, not uniformly or randomly selected samples across the state. And we need to be very careful. So you need to be very careful using that type of modeling data to make any generalized assumptions. And correlation is not causation. So we need to be very careful about making those kinds of predictions and taking actions on that. And last thing I'll say is one of my favorite quotes, having been a math modeler all my life, is that all models are wrong, some are useful. And I'm sure this is very useful. I'm sure it's very useful. But we just need to be very careful in how we use the data.
Yeah, totally. And I will say, like, I am not the person who was involved in the modeling. So me trying to explain what our modeler did, why and how, is very much, I am usually a communicator of the findings. I'm not so much a communicator of the methods. So there's a lot of possibility that some of the ways in which I communicated this were in ways that my mathematical colleagues would go, that's not what we did. So I have Mike Hallworth's email on the final slide, and I definitely encourage you to reach out to him and chat more with him directly. He'd be the best person to talk to about the modeling.
And also, I just want to follow up a little. You said based on 4, it's not based on 4 sample sites, it's based on all of these sites all across the state.
Sure.
They just highlight, they pulled out the 4 to show how many dots, how many samples were in those.
Right, which is a large
Selections.
percentage of the sampling was done in those 4 specific locations.
Oh, there's
In
other,
other words, it's not a uniformly random sample across the state sampling.
no,
10 million.
although interestingly, we heard our Fish and Wildlife Department the other day say, use a similar method for beavers.
Yeah.
So I don't think they're alone with this. At any rate, was it
I just,
Sarita?
yeah. So
Representative?
just to clarify, when you make assumptions in science as a scientist, isn't that what all data is based on? You make an assumption and then you do the research to either substantiate your assumption or prove it that it's not accurate, and it's verifiable and it's replicable and it's peer reviewed. So is it safe to, I'm assuming that they followed a scientific method
Oh, yeah.
to arrive at these conclusions.
Yes.
Okay.
Yeah. And I believe that, yeah. Any other questions before I close it up? Yeah, so so the Vermont Atlas of Life, we've been doing this for 10 years now. We use a lot of different approaches for collecting our data. Community science is the main way, but that looks very differently kind of across the suite of ways in which we collect community science data. And we're excited that beginning to get a baseline of data for Vermont will help inform decisions that are being made in the future. Obviously, it's not that we did 10 years of research and it's like, this is done. We are still collecting data. This is kind of an ongoing project. There will be new things coming out. And we're excited to keep folks in the loop and share more as we go. One project we have going on right now is we're doing the second Vermont State Butterfly Atlas. So we're doing, so we have survey blocks that folks visit throughout the summer months over a period of 3 years, 5 years, sorry. And that we collect data on what butterfly species are present, and we're going to compare that to the original study that was run decades ago, and then just to start to understand how butterfly diversity might be changing for the state. So these are the types of projects that we do kind of on a smaller scale, but then help inform some of these larger picture inquiries. And I wouldn't be able to give this presentation without thanking folks who submit to iNaturalist, eBird, eButterfly, participate in our studies, really get involved in science in all the ways that we try to make possible. Like I said, it is really hard for biologists to collect a substantial amount of data on this landscape level scale without the help of volunteers. And so they make our work possible. Funding sources are available here. It's a mixture of private, state, and academic funding. And if you have any additional questions that I wasn't able to answer today, I really encourage you to reach out to Kent or Mike. Their emails are here. They're both more than happy to talk to anyone and answer questions. So,
Great. Thank you so
thank you all
much
so
for
much.
joining us this morning.
Yeah.
Yeah, it's really, it's so cool to have people all over the state be able to share their observations.
Yeah, the crowdsourcing that kid's really cool.
Yeah. All right, cool. With that, we are adjourned for the weekend.
We